Now, come to the beauty of this convergence. So here, let x equals secant xn and y equals secant yin are the sequence of real numbers. Xn and secant yin are sequence of real numbers such that xn converges to x. Xn converges to x and yn converges to y. And let us see any real number. Then our first we prove x plus y converges to this capital X plus capital Y. X plus y converges to this small x plus small y. This is our first requirement. X plus y converges to x plus y. Means when xn converges to x and yn converges to y, then we have to show that the sequence xn plus yn converges to x plus y. This is the requirement. How to prove this one? So its proof is, it is so easy. Why? Because it heavily depends upon the definition of the convergence. Here xn converges to x. Xn converges to x means for all epsilon is positive, there exists some k1 following n such that modulus of xn minus x less than some epsilon by 2 for all n greater than or equals k1. Okay. Yn converges to y means for all epsilon is positive, there exists k2 following n such that modulus of yn minus y strictly less than epsilon by 2 for all n greater than or equals k2. Okay. Now, put k equals maximum of this k1 and k2. Maximum of this k1 and k2. K equals maximum of this k1 and k2. So these two are called. These two equations are called for all n greater than or equals k. Okay. Now consider. Now what's our aim? Our aim is xn plus yn converges to x plus y. So for that consider this xn modulus of xn plus yn minus of x plus y. Okay. So which equals mod xn minus x plus modulus of mod xn plus x plus yn minus y. Mod xn minus x plus yn minus y. By triangle inequality, it is mod x less than or equals mod xn minus x plus mod yn minus y. But mod xn minus x less than epsilon by 2 plus epsilon by 2 for all n greater than or equals k under this by using these arguments. Means modulus of xn plus yn minus of x plus y strictly less than epsilon for all n greater than or equals k and for all epsilon is positive. So that means we here clearly by definition of convergency xn plus yn converges to x plus y. So finished. Okay. Right. So what about this xn minus yn? That's our next argument. Here xn plus yn converges to x plus y. What about xn minus yn? Is it converges to x minus y? Look here. So for that, xn converges to x, yn converges to y means it is true for every n greater than or equals k. Why? Because we choose k is maximum of this k1 and k2. Okay. All of these arguments are same. Now instead of xn plus yn, we consider it is x minus yn minus x minus y. So it is consider this modulus of xn minus yn minus of x minus y. So this equals, this can be rewrite as it is modulus of xn minus x, modulus of xn minus x, okay, plus y minus y. Agree? Modulus of xn minus x, there is minus yn plus y. By using triangle inequality, it is less than or equals mod xn minus x plus mod y minus yn. Mod xn minus x less than epsilon by 2 plus mod yn minus y or y minus yn less than epsilon by 2 equals epsilon for all epsilon is positive and for all n greater than or equals k, that means this xn minus yn converges to x minus y. Okay. Now, what about xn yn? That's our next question. Xn, if x equals xn, y equals yn, they are converges to x and y respectively, then xn plus yn converges to x plus y and xn minus yn converges to x minus y. Now what about xn yn? Is it converges to x y? That's our next. So again, xn and yn are converges to x and y respectively, then these all arguments are held. Okay, no change. Finally, it is true for every n greater than or equals k, and k is chosen as in this way. K is nothing but a natural number. Clearly, k is a natural number. Now, consider modulus of xn yn minus xy. In order to prove xn yn converges to xy, we have to show that modulus of xn yn minus xy strictly less than some epsilon for all n greater than or equals k. Okay, where epsilon is positive. So you can rearrange this as mod xn minus yn minus xy can be rearranged as it is modulus of xn yn minus xn y plus xn y minus xy. Xy. You can introduce, yes, here. You can introduce xyn and minus xyn simultaneously here. Xn yn minus xy is nothing but xn yn minus xyn plus xyn minus xy. You can introduce this x into yn or x into y, whatever x into yn simultaneously. So what do you get? Consider these two. So which is equals here xn yn minus xy. That is modulus of xn minus x into yn plus here x into yn minus y. Okay. Triangle inequality. It is less than or equals mod xn minus x into mod yn plus mod x into modulus of yn minus y. Clear? But what is mod yn? So here y equals yn. What is yn? Y equals secants yn. And it is not, we know that secants yn, xn and yn are convergent sequences. We already proved a result. All convergent sequences are bounded. Convergency should imply the boundaries. All convergent sequences are bounded. So yn is a convergent sequence, yn is bounded. Okay, yn is bounded and x is a convergent sequence. Since x is an element of that one, x converges, so it is also bounded. Means it is less than or equals m into modulus of xn minus x, mod yn is m. Again plus modulus of yn minus y. Again mod x less than or equals m. Okay. Now for, since xn converges to x, then for all epsilon is positive, there exists k1 fall in n such that this xn minus x less than epsilon by 2m. Why? Because epsilon is arbitrary there. We can choose epsilon, instead of epsilon here is epsilon by 2m, because epsilon is a sufficiently small positive quantity. Here again you can choose this. So these two are held for every k fall in n. Therefore, it is strictly less than, it is m into, what about this one? Less than epsilon by 2m plus epsilon by 2m. Okay, so epsilon by 2m plus epsilon by 2m is epsilon by m and m, 2 epsilon by 2m means epsilon by m and m cancelling each other equals epsilon. So it is modulus of xn, finally modulus of xn minus xy strictly less than epsilon for all n greater than or equals k, where k is a natural. That means from here we can conclude that sequence xn yn converges to xy. Okay. And finally, let C is any real number. What about C into sequence xn? Is it converges to Cx? When xn goes to x, or when xn converges to x, can you say that the Cxn converges to Cx? That's our next question. That's very interesting. Why? Because we choose yn. Yn is suppose yn is a constant sequence, etc. Yn is a constant sequence. Yn equals C, 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 etc. So surely the sequence yn converges to C, let it be y. Okay, it converges to C. Sequence yn converges to C. So we know that xn yn converges to xy. Thus we already proved. Here what is xn? Sorry, what is yn? C. So it is C into xn converges to C into xy, because yn converges to C means this C is taken as some y. Okay. So these are the very important properties of the convergence of two sequences. When two sequences are converges, their addition converges, their subtraction converges, their multiplication converges, their product converges, and that is the scalar product. So it is the scalar multiple of a sequence that should also converges to the respective fields. Okay, xn converges to x, xn plus yn converges to x plus y when yn converges to y, and so on. Okay, so this is nothing but an important research regarding about this convergency. Okay.